1.6. We are talking about absolute value equations, which is what we had in the warm-up, right? And, of course, we can't stop there. We're also going to talk about absolute value inequalities. All right. So let's start with the equation ones. So when we're talking about an absolute value equation, let me say this a different way. Absolute value equation. The basic absolute value, if I have the absolute value of x, and it equals, let's say, a number a. Any number is just a variable, right? If I have that absolute value by itself, that means that a is that far away either direction. So I actually can rewrite this as x equals a and x equals negative a. That tells me how far away from x or 0 I am. Okay? Yeah. All right. Now, the real trick is, before you can split it into two separate equations, you have to have the absolute value by itself. So, step 1, isolate the absolute value. Step 2, break into two equations. You're going to take that absolute value and set it equal to both the positive and the negative. Step 3, solve each. All right, solve each. That's all there is. So, do a couple examples of the equation ones. All right, when we're doing equations, because it is just a solution, just an answer, it's equal to those two numbers, we don't have anything to graph, and we don't have interval notation because it isn't a solution set. It's one single or two single answers, right? All right, so here we go with example number 1. I'm simply going to ask you to solve. Let's say I have the absolute value of x plus 4 minus 7 equals 3. Started super easy. So we have to isolate the absolute values. So the first thing we have to do is add the 7 to the other side. So I have the absolute value of x plus 4 is equal to 10. Now that the absolute value is by itself, we have to write two separate equations. There is always 2 when there's an absolute value. So we have x plus 4 equals, now I personally like to write my negative on the left because where are negatives? On the left. So I'm going to put my negative 10 on this side, and I have x plus 4 equals positive 10. So to solve this, I'm going to subtract 4 from both sides. So I have x is equal to negative 14. Over here, I'm going to subtract 4 from both sides, and I get x is equal to 6. Does this sound familiar? Yes, good. All right, let's try another one, but we got to make it tougher. Example number 2. All right, let's say I have 2 absolute value, 3x minus 1 plus 4 is equal to, you want 10? 10 it is. All right, so we have to get this absolute value by itself. All right, we got to isolate it. Nope. These are like, I call them like a jail bar cell, whatever. You cannot get in there, right? You cannot distribute in. You cannot. So the first thing we have to do is get this part by itself. Imagine this absolute value is just a variable. If I was solving for that variable, the first thing I would do is subtract 4, right? So I'm going to subtract 4 to the other side. So I have 2 times the absolute value of 3x minus 1 is equal to 6. Now, this 2 is just a coefficient in front of my variable of the absolute value, okay? So to get rid of the 2 in front, I'm going to divide both sides by 2. So that means on this side, I'm left with the absolute value of 3x plus 1, or sorry, minus 1 is equal to 3. Now that the absolute value is all by itself, we can split it into 2 separate equations. 3x minus 1 equals negative 3, and 3x minus 1 equals positive 3. First, we're going to add 1 to both sides. We get 3x is equal to negative 2. Divide by 3. And x equals negative 2/3. Let's go over here to this one. I'm going to add 1 to both sides. We get 3x is equal to 4. Divide both sides by 3, and we get x equals 4/3. Any questions so far? All right. Gentlemen. Okay. Example number 3. Again, let's solve this one, then we'll go to inequalities. Say I have 2, absolute value, 5x minus 1 plus 7 equals 1. So what's the first thing we're going to do here? Subtract 7 from both sides. So I have 2 times the absolute value of 5x minus 1 equals negative 6. Divide both sides by 2. We have the absolute value of 5x minus 1 is equal to negative 3. Can an absolute value ever equal a negative number? No, it can't, can it? So this, because it cannot equal a negative number, that doesn't matter what I can put in for x, it can never equal negative 3. This is no solution. So before I split it into 2 equations, you look at it and make sure that it makes sense, right? Everybody understands that one? Okay. Let's talk about the inequalities then. Obviously, if we have inequalities, we have 2 different types. We have and we have or. Then when we talk about the absolute value, inequalities. If I have the absolute value of x is less than or equal to a number, this less than sign means it's going to be an and problem, which means your solution set is going to be sandwiched between 2 endpoints, right? If I have the absolute value of x and it's greater than or equal to a number, that is an or problem. So you will know, looking at the problem at the very beginning, when you first get the absolute value by itself, what type of compound inequality it's going to make, right? Okay. Here are the steps when there are inequalities. Step number 1, isolate the absolute value. Step number 2, once you have the absolute value isolated, we're going to split it into 2 separate inequalities. Split into 2 separate inequalities. I'm going to abbreviate inequalities there. The first one is exactly like you see it. So in the first one, just drop the absolute value. The second one, you're going to flip your sign and make negative. Step 3, you're going to solve each inequality. And of course, when we solve an inequality, that means step 4, you're going to graph it. And of course, if you solve an inequality and you graph an inequality, you're also going to write the interval notation. Alright, so let's try a couple of these. Example number 4, I believe I'm on, right? Yeah, thank you. Example number 4. Let's say, we'll start off kind of easy. Let's say I have 2 times the absolute value of x plus 5 is less than or equal to 12. Alright, so we need to get the absolute value by itself first. What's the only thing I have to do that? Divide by 2. Very good. We're going to divide both sides by 2. So I have the absolute value of x plus 5 is less than or equal to 6. Now, right now, looking at that, I'm going to know this is an AND problem. Kind of gives me a clue where I'm headed here. I know that because it's less than as my sign. Now, I'm going to write 2 of my inequalities. The first one, remember how when we did the equations, I put the negative 1 on the left? I'm going to do the same thing here. I want to put the negative 1 on the left. So I'm going to take x plus 5, flip my sign, and make it negative. My other one, I'm just dropping those absolute value signs. X plus 5 is less than or equal to positive 6. Solving this first one, I subtract 5 to the other side, and I get x is greater than or equal to negative 11. Over here, I subtract 5 from both sides, and I get x is less than or equal to 1. On my number line, at negative 11, I have a closed dot, and this goes to the right because it's greater than. At 1, I have a closed dot, and it's less than, so it goes to the left. My interval notation starts with a closed dot, which is a bracket. Negative 11 all the way to 1, the closed dot, which makes a bracket. Exactly. Do we remember doing this as well?
Yeah, that's so hard.
Okay, so let's try another one. Example number 5. Yep. How about 2, absolute value of 3x minus 1 is greater than 10. So first thing I have to do is get the absolute value by itself. So we're going to divide both sides by 2. Very good. If that was a negative 2 on the front, what would I have to do? No. If that was a negative 2 on the front, and I'm dividing by a negative 2, we'd have to flip the sign. Very good, right? Remember when you're working with an inequality, divide by a negative, you got to flip that. Okay, just wanted to bring that up. You just never know when that might sneak in there. Okay? So we have 3x minus 1 is greater than 5. All right. So this time it's a greater than sign. So what type of problem are we going to have? An OR problem. I kind of put that over here so we don't forget. Which means that when we go to graph it, it better go in opposite directions, right? So our first one, again, I like to do the negative 1 over here. So 3x minus 1. I flip my sign and make it negative. Positive 1 on this side, I just drop those absolute value signs. Yeah. So now we're just going to solve each. First one, I'm going to add 1 to both sides. So I have 3x is less than negative 4. Divide both sides by 3. And we get x is less than negative 4/3. Over here, I'm going to add 1 to both sides. We have 3x is greater than 6. Divide both sides by 3. And we get x is greater than 2. All right, on my number line, at negative 4/3, open or close that?
Open.
And it goes to the left. At 2, do I have an open or close dot?
Open.
And it goes to the right. Our interval notation starts at this arrow, which is negative infinity. Goes to negative 4/3 with a parenthesis. Remind me again, what do I put in the middle?
U.
Good. Then we have a parenthesis to infinity. So I need to know, before I go on to the next part, do we need more examples? You guys be honest, 'cause I'm happy to do, how about one more?
No.
We're all good? Are you sure? I think one more sounds good too. Okay. Oh, we still have more to talk about anyway, so get over it. Example number 6, right? All right. So what if you ended up with something like this? Let's say I have 1/2 the absolute value of 4w minus 2 plus 6 is less than or equal to 12. All right. So we have to get that absolute value by itself. What do we get rid of first?
6.
Okay, so we're going to subtract 6 to the other side. So I still have 1/2. The absolute value of 4w minus 2 is less than or equal to 6. Now, how do I get rid of 1/2?
You divide by 0.5.
Okay.
Divide by 0.5.
Times it by 2. Exactly. Okay. So if you divide by a fraction, if that's how you're choosing to think of it, and that's what you said, Logan, right? When you divide by a fraction, you're really multiplying by the reciprocal. Exactly. And what is the reciprocal of 1/2? 2. Exactly. Or the other way to think about it is you're clearing the fraction, right? If I'm timesing both sides by 2, aren't I canceling that 1/2 out in front? So whether you think of it as multiplying by the reciprocal or clearing the fraction, it's both exactly the same. So we have the absolute value of 4w minus 2 is less than or equal to 12. All right. Now we can split it up. I have 4w minus 2 is greater than or equal to negative 12. And I have 4w minus 2 is less than or equal to positive 12. Adding 2 to both sides. I have 4w is greater than or equal to negative 10. Divide both sides by 4. And w is greater than or equal to negative 5/2. Over here, I'm going to add 2 to both sides. So Say 4W is less than or equal to 14.
Were you supposed to change the sign or use the X?
I did that right here. When I made it negative, right? Yes?
Yeah.
Okay. All right, divide both sides by 4. So we get W is less than or equal to 7/2. So on my number line at -5/2, I have a closed dot, and this goes to the right. At 7/2, I have a closed dot, and it goes to the left. My interval notation then would be bracket -5/2 to 7/2 with a bracket. So any number that falls within that interval, that solution set, will make my inequality work. Okay? All right. So I really only have one more thing to talk about. So here, I want to talk about writing a compound inequality as an absolute value All right, so what I'm actually saying is if I have a compound inequality, and for example, and let's say I have 3 is less than or equal to x less than or equal to 5. What I want to do is write the absolute value equation, or absolute value inequality, that gets me that solution set. That's my goal, okay? So here's how we're going to do it. This is the easiest way out of all the years. It's the easiest way I've ever found to teach everybody. So when we write it, you're going to have an absolute value. Whatever this middle variable is goes first. We have our variable minus. Next, inside our absolute value is the middle term. So right here, this is our middle term. So what falls exactly in the middle between 3 and 5? 4, yes. So this would be a 4. Our sign, because it's an and problem, is going to be less than or equal to. The number that goes on the end is the distance from the middle to either end. Yes. All right, so the correct answer to this one, you guys are all correct, it's the absolute value of x minus 4 less than or equal to 1. Because the solution is 3 is less than or equal to x less than or equal to 5. We're going backward. We're writing the absolute value inequality. Okay? So you're going to be given the solution set. You've got to write the actual inequality to begin with. All right? And this works every time. So here is example number 7. Guys, make it sound like I've been talking forever. Let's say I have 10 is less than or equal to m less than or equal to 20. The very first thing you do is find the middle number. Find middle number. I agree. How did you find that? It's directly in the middle. How do you figure it out, though, if you can't tell? Average it, exactly. You're going to take your two ends, add them together, and divide by 2, right? Okay. Then the next thing, before you can write it, you need to know what is that distance from 15 to 20 and 15 to 10? 5. All right, now we can write our equation. We have the absolute value. My variable is m minus my middle number, which is 15, less than or equal to 5. Okay? Any questions on that? You have 4 of these on the worksheet. Everybody's clear on what you have to do? Okay. All right. Let me get you the worksheet then.